Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle. And it's called Chaconopia, Intro 9 by 9 by Mad Tias. And here are the rules. We have chaos construction rules, which means the grid has to be divided into 9 regions of orthogonally connected cells. And each row, column, and region has to contain the digits 1 through 9 once each. So for an orthogonally connected region, that means you have to be able to go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. So this is a valid example of an orthogonally connected region because to get from this cell to any other cell, you can get to any other cell just by going through edges, all while staying within the region. This would not be a valid orthogonally connected region because this cell cannot get to any other cell in the region just by going through edges, all while staying within the region. It would have to go through a corner, or it would have to go outside the region by going through edges, and that's not allowed. So that is chaos construction rules. We also have roles, whereas cells take on roles if certain conditions are met. And these roles increase the value of those cells. Only if none of the conditions are met, which are described below, is met, the value of a cell is its digit. If more than one condition is met, the cell always takes a role with the highest value. So the value of any cell is basically its digit unless it has a role. And if it meets any of the conditions for the role, it basically has that role. Or it has a higher role if it has a higher value for that. So there's like a basic you have the basic value of the cell, then you have a role number which is slightly higher, which is the farmer role. You have a role that's higher than that, which is the merchant, and then a role higher than that, which is a diplomat. So if it can take it takes the highest role it can, and if it can't take any role, its value is the value of the digit. So here are the role mechanics and the values. X equals the digit in the cell. So there's the farmer role, which is just above the normal, I guess, peasant role or whatever. So you have the peasant or peon, which is a value of x, which is the value in the cell. You have a farmer role, who has a value of 2x, which is 2 times the digit in the cell. And to become a farmer, a cell needs at least x cells, which is the digit in the cell, to become, including itself, of its own region in the 3x3 centered on the cell. So for example, this we know is a farmer because it's an F in the bottom right hand corner. So this is a farmer, and say to be a farmer, it needs at least X cells, including itself, of its own region in the 3x3 area centered on the cell. So of these 9 cells, so if this were 9, we know it's a farmer, that means all 9 cells would have to be in the same region as it. Because a farmer cell needs at least X cells, which is the digit in the cell. So if it's 9, it must need at least 9 cells, including itself, of its own region in the 3x3 area centered on that cell. So if this were, say, a 6, that means at least 6 of the 9 cells surrounding this cell, including itself, must be of the same region. So it could be something like, this would be valid if these were all green region and this was, say, red or blue and then dark. This would be valid as a farmer because, and the value of this would be 12. because it has 1, 2, 3, 4, 5, 6 cells of the same region of it as the cell in that is the farmer's cell. So that's farmer. We also have merchant, where to become a merchant, there has to be at least one foreign region that occupies at least X orthogonally and or diagonally touching cells of the considered cell. And I believe that does not include the cell itself. Oh, well, obviously it's not foreign, right? It's the same region. So, if this is a merchant, if this were a certain cell, so say, well, one thing is it can't be 9 and it can't be 8, right? It can't be 9 for obvious reasons because it's already part of its own region. But it can't be 8 either because it has to be orthogonally connected to the rest of its region. But this could be, say, 7. So if this is 7, that means every cell but one that is touching it, at least 7 have to be in at least one foreign region. No, sorry. That means, if this is 7, that means one foreign region occupies at least 7 orthogonally and diagonally touching cells of the considered region. So that means there would have to be one region which is all like in the same region, which is occupying the 7 cells here. So this is a valid example of a 7 merchant because this region here contains 7 of the cells that touch it orthogonally, which is horizontally, vertically, or diagonally. And that's what a merchant is. And then finally, we have diplomat, which has a value of... So the merchant has a value of 3 times whatever the digit is in its cell. And a diplomat has to have a value of 4 times the digit in the cell. And to become a diplomat, a cell has to be orthogonally and or diagonally touched by at least X different other regions. So for this diplomat, obviously you can't have 9. You can't have 8 either. You potentially could have 7 if, so say this is pink region. If you have 7 other regions touching it, and it can't be 8 because this has to be orthogonally connected to its own region. But if this were, say, 7, this would potentially be valid. If, like, you had all these cells in different regions. So this would be a valid example of a diplomat with a 7 value because it has at least 7 different other regions touching it. And again, remember, if it matches at least whatever the role that it matches the highest, which would be the diplomat, then merchant, then farmer, it must take on that role. Or it always takes on that role, I guess I should say. And then finally, we have clues, where a black number in the top right corner of a cell gives the value of that cell. A black letter in the bottom, so that means this value is 21, this value is 12 in that cell, this is 9, this is 4, 6, 4, 4, etc. These are 12. This, and a black letter in the bottom right of the corner gives the role of that cell, which is farmer, merchant, or diplomat. And so this is a farmer, these are farmers, these are merchants, and this is the only diplomat in the grid that we know its role is. Anyways, those are all the rules of this puzzle. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Interesting. So we have a merchant. This it has to be a merchant. These two both have to be merchants because they have a value of 21. And the only way you get to 21 is 3 times 7. So these are also 7s as digits, and they're merchants. So in the merchant, that means you have 7 digits which are of a different region than it. And it must be the same region that occupies at least 7 orthogonally and diagonally touching cells. So this cell, has 7 cells which are not of the same region. These can't be the same region because they're both 7. So this, I'm going to mark this as light and this as pink. The pink has to either go this way or this way. And then it must... Okay, so actually let's make this pink and this light. Let's make actually one of them light and one of them medium. So we'll make this medium and we'll make this light. So 7 of these cells must be light because the region has to have... The other foreign region has to occupy at least 7 of the cells surrounding this. Well, 2 of them are guaranteed to be the medium gray region, so the rest has to be light. So these are all light, and then one of these is medium gray, and one of these is light. That means for this region, one of these is light, and the other ones are medium gray. Okay. That means since these are all medium gray, right, this is a merchant. To be a merchant, there has to be at least one foreign region that occupies. Okay, farmer needs at least X cells, including itself, of its own region in the 3x3 area centered on the cell. Okay. So we know these are bound. Okay, so let's mark all the boundaries. So we have the entire grid, edge. And we know these are definitely boundaries, and these are definitely boundaries. Okay. Farmer, the cell needs at least X cells, including itself, of its own region in the 3x3 area surrounding it. Okay. This is a merchant, and that one foreign region occupies at least X cells. So this cannot be a merchant, and it cannot be a diplomat. So obviously, okay, so diplomat almost always is going to have... So every one is going to be at least a diplomat. Right? Because unless it's in the very center of a 3x3 box, or it's on the edge. An edge potentially could do that too. Because it would basically have to be touched by at least one other different region. Excuse me. 2. So say this was light, and then this would be medium. This is a farmer, but not a merchant. To become a farmer, a cell needs at least X cells of itself of its own region. So this is 1, 2, 3, 4. It could be 5 at most. But so this would be 5 at most because you have 8 cells already that are light, and this would be the ninth. Well, yeah, it could be 5 as a farmer, and it would not be merchant. So this would have to be a 5 if that were the case. So that means whichever light is here has to be a 5, guaranteed. Right? Because it has to be... It sees 4 cells in the gray region. So this cannot be gray. Because if it were 4, then this would definitely be a merchant. So this would have to be 5, and therefore this would be light, and that would be light. Okay. And that works both ways. For merchant, this matches at least 4, so it's 4 or less, or it could be 5 or less. So these digits have to be 5 or less no matter what. Right? Because if this is light, this is medium then. This farmer sees 1, 2, 3, 4. So, okay, that's interesting. If this is light, again, this is not light, so it's gray. It's medium gray. If this is light, this is medium. That means to be a farmer, it can't be a merchant. And the merchant would be if it occupies at least... The foreign region occupies at least 4. The farmer then has to be 5. So this would be light if that's the case, and then this would be 5. If this is medium, and this is not medium, this would see 4 here. So either way, this is 5, I think, guaranteed. Right? Because merchant would match if this is 4, and this is light. We know it's a guaranteed farmer, and there's only 8 cells in the medium region, too. So this is guaranteed to be 5 no matter what. So this is 5, and this is the matching light or medium that matches it, right? That means the extra light in this region is either here or here. The medium does not have to be here. So this could be medium, it could be green or some sort. The merchant... So again, if this is light, this is medium. The merchant... Interesting. So if this is light, then this would have to be light also, to have 5 fit the farmer. And not match the merchant. Because if it's 4 or less, it would definitely match the merchant, because these 4 are of a different region that occupies at least 4 cells. Interesting. Also, we know these 12s have to be a role. They cannot be the peon or the peasant role. They have to be farmer, merchant, or diplomat. But, so say... Say this was not light, this was medium. Then this becomes not medium because this has to be surrounded by 7 cells in the foreign region. This has to have 5 cells in the 3x3, which are of the same region. So it would have to be medium here, which would mean this is light. If that were the case, to add up to 12, can it be the farmer rule? Needs at least X cells, including itself. It would have to be 6 times 2 if it's farmer. And this does not have 6 cells that are in the 3x3 region surrounding it. So that does not work because this is already, well, the light's already taken. It's already here. So cannot be farmer. Can it be merchant? To be merchant, it would have to be 4. So there would have to be one foreign region that occupies at least 4 cells that touch this. Well, this is all done as a region, though. So it can't be 4, and anything here would only occupy 2 cells. So this is not possible to be 3 times 4. Then it would have to be 4 times 3. Where it must be touched by at least 3 other regions. That's 1, 2, 3. It's possible. So only if this is a diplomat can that work. If this is medium. What about if this is actually, then what is this case? I think it also has to be diplomat, right? Farmer, again, you can't have 6 cells of the same region because this is already not a different region. 3 times 4 has to, a foreign region has to occupy 4 cells. It can't be because this is 2 at most here. And it has to be a diplomat, and that's 4 times 3. So these are 2 different regions here. Because it could be touched by this and then 2 other regions, and that would make 3. Okay, what if this is light? So that was if that's medium. If this is light, then this is not light. This is medium. This light must be light here. Oops, must be light. Again, you have the same problem. This is, so this role, no matter what, I think has to be, it can't be a farmer because it needs 6 cells in the same region. Can't be merchant because it needs one foreign region having 4 cells, which it can't be. This is 3 at most. Or it's diplomat. So it's 4 times 3. So this is always a diplomat. This cannot be farmer. I think this also has to always be a diplomat. Right? If it's farmer, it's 6 of the same cell, but these already are different regions. You have a foreign region. The gray, it would have to be 4. So say it was like this green region. If it's 4 and it's green, the problem is it needs one region that will have 4 cells in the surrounding 9 in the digits in the cells touching it. But this is already 8 cells here, so it could be at most 1. So then that's 3 cells. This is 1 cell, and any other one would be 1 or 2 here. So that's not possible either. This has to be a diplomat also. So no matter what, these are both diplomats, so these are both 3s, which is 4 times 3. And they must be touched by at least X other different regions. This could be green, it could be touching another region here. Or it could be light, and that could be touching 2 different regions here. So we know this has to be some other region. This has to be some other region. So we have dark, and then I guess you could have pink or whatever. This is guaranteed to be a different region. So this is... So this is guaranteed to be a different region. And this is guaranteed to have... If it's green, it could be light and then medium and then another one. We don't know. Or if this is light or medium, it has to be with 2 different regions. Whatever it is, this has to be a distinctly different region. So I guess we'll make that red. This will make dark and pink, I guess. This is guaranteed to have two different regions because if this is medium, that means this is light. Or sorry, this is medium. This has to be medium to match it. Yeah, these two are basically the same region. And it cannot be this region because we see only one foreign region here. We need to see three total, and this would be 2 and 3. So whatever it is here, it only sees one foreign region here. It must see 2 or 3 here. This is a merchant. Okay. So we know for certain this is a separate region, and this is a separate region. This dark must go this way. Okay. So this is a 3, that's a 3, but we don't know if it's a green 3, a gray 3, or a light 3. This is a diplomat. This merchant, what can it be? This is guaranteed to be a different region, because if this were green, green would have to go out somewhere, so it would have to go. This would have to be the same region. We'd have 1, 2 different regions here. We would need a third, so that would be third. If this is light or medium gray, then we need these two to be essentially different regions. So this is a diplomat. This is a merchant. Could be 1. Could be 2. This is different than this region. So if these are all light, it could be 3, 4, or 5, I think. Right? Because, well, actually, is that the case? If this is medium, that means this is light and light. So the foreign region would be at most 4 here. If this is light, that means this is medium and medium. I don't think that's possible then. If this is light and this is medium, medium, then the light also has to be here. Because there's no other place for the light, essentially, to go expand as a region. So then this would be 4 at most again. So this is 1 through 4 here. So this can be, it touches, these two are the same region. So it could be at least 6 different regions. 1, 2, 3, 4, 5, 6. Sorry, at most 6 different regions. So this is 1, 2, 4, 5, 6 as a cell. For merchant here, these could all be the same region. So 3, or you could have 1, 2, 3, 4, 5. You can't have 5. You could have 4. So this is 1 through 4 here as a merchant. As a farmer, none of these cells are going to be the same region. So this is up to 6, because it could be 6 that way. This is a merchant. So none of the medium gray regions can be... Okay, so these all have to be light. cannot be 3, cannot be 7. So it's 1, 2, 4, 5, 6, 8, and 9 as possibilities. This can't be 5 because of the 5 in the box or the column. This can't be 5 because of 5 in the row. Um, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Oh, wait. No. Okay. Oh, I miscalculated. Apologies for that. There are 2 other ones it could be. So this could be merchant, and in fact, I think it has to be. So this is guaranteed to be 5, but it's 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. We have 2 more cells possible. So if this is not light, this is medium. That makes this light. This is 1, 2, 3, 4, 5, 6, 7. This has to be light then, and then this has to be light. So that's guaranteed. 1, 2, 3, 4, 5, 6, 7, 8, 9. Does this 12 actually match? And I think the answer to that is no. You can't have a 6 here, and this value be 2 times 6 because in this 9 by 9, 3 by 3 area around this cell, there's not going to be 6 light cells. Can it be a merchant then? And the answer to that is no, because it'd be 3 times 4. And that would mean one foreign region occupies at least 4 cells. Well, these are all the same region, so that's not foreign. These would be foreign, but that's only 2 cells, so that doesn't work. For diplomat, you have to be touched by at least 3 other regions. This is 1, and this is 2, but that doesn't work. So this can never be medium. This then has to be light because of that. So this is light, which makes this light. That means this can't be light. This has to have 7 cells. This has to have 7 cells surrounding it, which have to be all medium, or all the same foreign region. So we know guaranteed this is definitely this way. This is a merchant. It sees at least 4 here, so this is 1 through 4. So the same problem arises here, right? If it's a farmer, it would have to have 6 there. It can't. If it's a merchant, I guess it could be... No, a merchant would have to have 4. And this has to have 3 here. Right? This would be 3 different cells. This is 5, including itself in its own region, so it does. Merchant would have to be 3 times 4, and this is not size 4. So that means this has to be 3. But then we have a problem. This has to be a diplomat. It has to be touched by at least X different other regions. So this has to be a different one, and this has to be a different one. But because this is different, that means this is blocked off here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. And this would have to be 4 times 3 also, but you have 2 3s in the region, which is not allowed. Oh, this has to be 4. Okay, so that guarantees what that is. Okay, so this is dark. This will be pink. So that's touched by 3 regions. This cannot be 3. Again, it can't be 6 as a farmer. It has to be 4 then as a merchant. And that means at least one foreign region occupies at least 4 of the diagonally touching cells. Or orthogonally touching cells. Well, then this is gray, which means both of these have to be gray. And that does work because of I miscounted. This was actually 7 cells, so that would be 8 and 9. So these are all the medium gray cells. Actually, I guess let's make this green. And this will make medium. And this will make dark. Actually, let's make this dark and this medium. So the green region's all done. That because we have 9 cells there. So that's 9. So this is all done. Okay, so the rest of the light gray region is 1, 2, 6, 8, 9. Okay. This is a merchant. And foreign region occupies 5 of the cells, so this could be 1 through 4. We have diplomat here. This is a farmer. Cell needs at least X cells, including itself, of its own region. So this is 1, 2, 3, 4 at most. So this is also 1 through 4. This could be 1 through 6. Cannot be 3 or 4, though. So it could be at most 6. It's 1, 2, 5, or 6 here. These have to be 1, 2, whoops. 1, 2, 3, 5, 4, 5, 6, 8, 9. Obviously, neither of this can be 4. This can't be 4. These can't be 3. And this can't be 5. And this can't be 5. Okay. This dark region must go that way. Medium gray merchant has to leave at least one foreign region that occupies at least X cells. So this could be 1 through 4. Because if it does go this way, that's possible for 4. But it can't be 5 because it would be blocked off as a region. What else do we have? Farmers at least at most 4. 4. So that means it's it could be the 4 itself. So this is a value of 4. That means it's 1, 2, or 4, right? As a digit. This is 1, 2, or 4. Cannot be the 4. So all the 4s have to be either 1, 2, or 4 as a digit. And these can't be 4 because, right? Because you can't have 3 times a digit equal 4. So it's either 1, 2, or 4 here. So this is 1, 2, or 4. This is 1, 2, or 4. This is 1, 2, or 4. 1, 2, 4. 1, 2, 4. We have a 1, 2, 1, 2 pair in row 4, which eliminates 1 and 2 in the rest of the row. So this sees at least 5 cells as a diplomat. 2, 3, 4. It could be 6. This to get to 8, it must be either 1, 2, 4, or 8. To get to 6, it's either 2 times something or 3 times something or 6. So 2 times is 3, and 3 times would be 2. So this is 2, 3, or 6. This is 2, 3, or 6. 9 can only be 1 times or 3 times something. So this would be either 9 times 1 or 3 times... So this has to be a 9. So this is guaranteed to be a 9 here because of a 3 in the row. And this is 3 or 9 here. We're not sure. So one of these is at least a diplomat, and the other one has to be the farmer. You know, that's always going to be the case. In the rest of row 4, we have a 3, 5, 6, 7, 8, 9 set. This obviously can't be 9 because of the 9 in the column. To be 12, you need a farmer of value 6, a merchant of value 4, or a diplomat of value 3. So this is 3, 4, or 6 for the 12s. Okay. Merchant can go up to 7. So this is 1 through 7 here. Hmm. Hmm. Okay. Obviously 9 does not fulfill farmer here, so that's fine. And merchant and diplomat because there's only 6 cells surrounding it, so that's not possible. Oh, that means 9 cannot be in the rest of row 1. So this can't be 9. Where is the 9 in the light region? It must be one of these 2 cells, which eliminates 9 in the rest of the column. So this can't be 9, and this can't be 9, so this must be a 3. That means this must be a merchant, and there has to be at least one foreign region that occupies at least X orthogonally and or diagonally touching cells. So it could be at least 3. So then this can't be 3. This can't be 3. That's interesting. This can't be 3 because of the 3 in the column. Therefore, one of these 4 is a 3. That's going to be interesting. Okay. This is 2 or 6. If there's a 6 here, there's no restrictions. If it's a 2, that's not very restrictive at all, right? It has to be a merchant, which means one foreign region has to have 2 cells that touches this cell. That's quite possible. This is very restrictive. Well, not very restrictive, but pretty restrictive. Interesting. Okay. This can't be a diplomat. Hmm. Okay. There are at least 5 different regions here. That's interesting. We don't know where the boundaries are, though. We have one here. So there's at least 4 here. It could be up to 5. Let's say this was a 6. That's interesting. So say that was 6, then these would all have to be different regions. So this could be like something like medium. You'd have like orange, blue, yellow, and red. So you would have to have that if that's 6. Obviously, this could be part of a completely different region. It doesn't have to be gray, but we're just using that as a placeholder. So this would be red would have to go that way. Yellow would have to go that way. Orange would have to go that way. This could actually go that way, so that's fine. Um. Hmm. Wait, this can't ever be 1. Right? If this is 1, it can't. There's no way it can get 8 times that value. So it's basically 1 times, 2 times, or 4 times. Okay, so again, let's go with 6. You have red here, yellow, yellow, blue. This is orange, orange, and this could be gray. So that could go out that way. Hmm. Hmm. So this is touched. Okay, so this cannot be. It could be farmer. If this is farmer, it's all blue here. That's interesting. Hmm. Or it's 8, in which case there's no way that it can be farmer or merchant or diplomat. Or 2 has to be orthogonally or diagonally touched by at least X different regions. Well, we have 1, 2, 3. You could have a 4th one somewhere. So that's possible still. Hmm. Um. That doesn't seem to go anywhere right now. Um. We have 2 cells here, which are 1, 2, and 4. Hmm. Is that the best way to approach it? I don't know. Remaining digits in column 1 are 1, 2, 5, 6, 7, 8, 9. Okay, that doesn't help us much. Hmm. I was hoping that this 6 would be very limiting, but it's not. Say this was a 4. That would mean this is all dark. This would have to be medium. And that would be 1 region, 2, 3, 4, 5. So that would force this to be 5. So this would have to go out this way. This would be a region, region. So this would be region, region. This would be region, region here. Does that tell us very much? Not really. That 4 would force this not to be a 4, so that would be a 1-2 pair there. That seems okay. Hmm. Doesn't seem to give us very much information. Well, okay. These can't be 9 because we have a guaranteed 9 in one of those two cells. Okay. One of these 3 is a 7. That doesn't help us much. 9 has to be one of these 4. That doesn't help us much. We have 4, 5, and 7 in one of these remaining cells, and the remaining digit here has to be one of these cells here. That also doesn't help us much. Six means you can't have a farmer have 6. Oh, that's interesting. To have a flat 4, it can't be a farmer, it can't be merchant 4, and it can't be diplomat of 4. How do we determine that? Let's see. Yeah, what happens if this is 6? So this would be red, this would be yellow, this would be blue. Actually, that's not guaranteed to be blue, but that would be blue. This would be orange. This would be at least medium gray. Could be a different color. Yellow could go this way. So for this to be a 4, it could have at most one extra foreign region. This could be 3 and 3. It cannot have 4 cells in the same region, so it must be 3. It has to exit out some way. So it'd have to be something like this or something. But it could be something like that, right? This could be red. This could be blue or pink. We don't know. We don't care as long as it's just only one extra. So it could do something like that. That seems okay. Or it could be something like this, technically. Then this would be, could be red here, and then this is a, like, I don't know, pink. That's possible. So then it would not have 4 cells in its region, in its own region in the 3x3 area. Yeah, that's possible too. Okay, not helpful. Hmm. Hmm. So one almost always fulfills diplomat, unless it's like surrounded by its own region. Two always fulfills farmer, so that's not helpful. Three is not guaranteed to fulfill farmer. Oh, wait. Two. Oh, no. I was thinking fulfilling farmer as two. That's not the problem. Fulfilling merchant as two means you cannot have a diplomat. Oh. That's interesting. Okay, that might be where it is. So say this was a 2. If this were a 2, that would mean you cannot have 2 foreign regions touching it. You could have one other one, but not 2. Because it would be just a farmer. So say this was 2. So say this was 6. Not 3. Say this was 6. That forces this to be 2. This 2 means it has to have at least one foreign region that occupies at least 2 cells. That's very possible. But it cannot have greater than 2 cells, 2 foreign regions touching it. That's interesting. Huh. So that's very doable on the edges. Oh, this is 4. Okay, this is definitely not 1. If this is 1 as a farmer... Okay, this is not 1 either. So this is a merchant and this is a farmer. That means 1 cannot be either of those spaces. Because it already sees... a foreign region already occupies 1 cell here. Oh. Wait, no, this is a merchant. Okay. It cannot be a diplomat because it's a merchant. So it has to be touching at least one other different region. So it's not touching, this is touching one other region, so that would not make it a merchant then, if that's the case. Same with this. This would be 1. As a merchant, it is not a diplomat to touch 2 because it's not has 2 foreign regions touching it. It has 1. This has cannot be diplomat and cannot be merchant. That's interesting. If it were 2, it's touching at least 4 other foreign cells. To not be a merchant, that means one region cannot occupy X cells. So these would all be different regions, but then it would be touching 1, 2, 3, 4, 5 different other regions. So 2 cannot be possible here because that forces this to be 2 here, 2 cells here, and then 2 cells here. So this could be 3. No. So if it's 3 and not a merchant, that means you cannot have 3 cells all in the same region of a foreign region. So this would be at best 2 and 2, but then this is 1, 2, 3 regions that it would be touching, and therefore it would fulfill the diplomat, but it says it's a farmer. So it cannot be 3. This is guaranteed to be 4. So this cannot be 4 here, no 4 here, no 4 here, and no 4 here. It is a farmer. So it cannot be touching 4 different... So this can't be the same region. So we know... Because if this were the same region, there has to be a boundary somewhere here. And it can't be 4 separate regions, so it's at most 2. So this has to be a different region than this. Guaranteed. Because if it weren't, that would mean this would have to be all the same region, and therefore this would fulfill merchant. Right, because that foreign region would occupy 4 cells at least. If there were additional regions, so these are both either red or pink. They have to be different regions because of the merchant constraint. It's not a merchant, so they cannot have 4 cells of the same region here. So these are different regions. Because if we try to have this being the same region going around, it would block this region off. So these are different regions then. And you cannot have another region here because that would be 1, 2, 3, 4 separate regions, which would be touching that cell, which would force it to be diplomat when it's not. So this is 4, which means this can't be a 4 here. Interesting. Merchant is very restrictive. That's fine. This is not a farmer. So it's either 8 or it's 2 as a diplomat, which is almost certainly guaranteed to be fine. Right, so 2 in the 4 space is very interesting. That means it fulfills the farmer role, but it cannot fulfill the merchant role or the diplomat role. So that means there's no one other region that occupies at least. So that means, okay. So say this was red and red. That means pink would definitely have to go this way. This would see at most 1, 2, 3, 4, 5 regions. So this would have to be 5. This would be like that. This would be like that. The pink would have to go out that way. The orange would have to go out that way. Obviously, this could not be a 2. Because it would be at least a diplomat. It sees 2 other regions, 2 other cells. So this would be 1 in that case, which would force this to be 2. So that's okay. 1, it already sees, it's a diplomat, fine. That works. It sees at least 1 other different region. This could not be 2 either, because it sees at least 2 other regions, right? Or touches at least 2 different regions. Could be diplomat, could be 1, could be 4. So both of those are okay. Obviously, if 6 is the case, that's a 1. Same thing. Can this ever be a 2 is kind of the question, right? If this is a 2, that would mean there cannot be a merchant. This is 1. Cannot be a merchant. And it cannot have a diplomat. So it can only touch 1 foreign region in 1 cell. That means it has to be a corner? Doesn't have to be. Okay, well, we are guaranteed that would force us to be 5. And these would have to be separate regions. Because you can't have 2 other foreign regions touch this cell. And you can't, that foreign region, so there's only 1 other foreign region touching it, at most. And it occupies only, at most, 1 orthogonally touching cell, or 1 touching cell. And these, so that means out of these 8 cells, there's only 1 of a different region. So this is essentially its own region. And there's only going to be 1. So 1 out of these is basically going to be different. So all of these are the same region. This would be 5. Because the orange would be 1 region here. This is 1, this is 1, this is another 1. So this would have to be yellow going down. This would have to be pink going down. One of these is orange, so this would have to be orange, because if it can't be a separate region. So either that one goes down that way, or this one goes up that way. So the medium gray definitely has to go that way, because this is definitely not part of that region. Because this is 8 here. So medium has to go that way, dark has to go this way. Medium has to go this way, dark has to go all the way around, which forces medium go there. This is dark. 1, 2, 3, 4, 5, 6, 7, 8. So this would not be 1. This could never be 2, because it would have to match a farmer but not merchant. And merchant already is fulfilled. Right? A foreign region has 2 other cells. So this would be 4. But we have a problem. This 4 matches farmer because we have already 4 cells in the same region here. So it would have to be 2 times its value, which is 8. So that doesn't work. So we've proven this has to be a 1, and that's a 2. So this 2 is a farmer, this 1 is a diplomat, that's fine. Everyone's going to be a diplomat, essentially, unless it's in the center of its region. It's surrounded by its own region. The 2 means it's a farmer, but not a merchant. So it can only touch 1 other cell. It could be something like that. It could be something like that. It could be something like that. So we don't have any guarantees here. And it cannot have 2 of the same region. So there's going to be 5 oranges here, but we don't know where. It could be 6, actually. It could be in its own central region. Yeah, 2 is always going to be at least a farmer. 1 is always going to be also at least a farmer. And it could be a diplomat. So this cannot be 2 here. This is 1, so this cannot be 1. Can this be dark? If this is dark, then that forces dark to be all around this way. So that's potentially possible. This would not be 4 anymore, so this would have to be 1. That seems feasible. Yeah. So this could be the dark region also. We don't know. Can this be 2? Is kind of a question, right? Okay, so if this is 6, that means the farmer cells have to be in 6 of the surrounding 9. If it's 4, that means a foreign cell must contain 4 different digits. So that's very distinctly different. But we don't really have very much else there. If this is 2, whatever region's here, you have the same issue, right? So then this would have to be a separate region. One out of these 2 would have to be a separate region. This would have to be its own region here. Maybe that way. So this would be... I mean, I guess these could be pink. So these would all be yellow. So because of that, it would have to be pink or red. And I don't think it could be red. If this is red, 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 yeah, the pink gets stuck here. So this would have to be pink. So this would all be pink. Which means that's not a 2. This is a 6. And we have 1, 2, 3, 4, 5, 6, 7. So the pink would have to be surrounding this. And then we'd have a contradiction. So this can never be 2. Right? Because one of these 2 has to be a different region, but the other one has to be pink. So we're guaranteed 8 pinks here, if that's the case, right? Because you can only be touching one foreign region, one other foreign region, and you can't. That foreign region cannot have two cells touching this cell. Therefore, all of these are the same region. It has to be pink. These are all the same region, so this must all be pink because this was pink or red. If we were tried red, the problem is this pink doesn't go out, so it's blocked. It's not a full region. So this one has to be pink then, because it must match that cell, and that's only pink or red. And then these two would have to be part of the same region, because they would be all pink. Therefore, it cannot be 2. Therefore, it must be 6. This 6 must have 6 cells in the surrounding 3x3 area. But we know there are 8 cells already accounted for, so there's only one more cell possible here. That makes this 5 at most. Oh wait, sorry, it's not farmer. It can't be farmer, in fact. Never mind, that works fine. So this would be 6, this would be 4. So that's okay. One of these would be pink. It cannot be that one, because then this would be a separate region. So this would be pink, this would have to go out that way. This would be a 5. Okay, so that does still kind of work then. This can't be 5, this can't be 6, this can't be 5. This can't be 2, this can't be 2. So this is fine. This is 4 times 3. That seems fine. This could be 2. It's fine. The pink cannot be 3 here. This can't be 2. This can't be 2 here. So 2 has to be one of these two, which means this can't be 2. 6 is here, so 6 cannot be there. So far, this is looking fine. This touches one other region. That's fine. At least one. That's fine. We have one pink somewhere around here. Say this was pink. Okay, so if this was pink, that means red would have to go this way. But this would not be a merchant where another foreign region occupies at least 3 of its touching cells. So this cannot work. So therefore this is red. If this is red, no, the red would have to go out. So this can't be red. This has to be another region. The red has to go out that way, so that occupies 4. That's fine. The yellow would have to go this way. This would be red. So red has to go out. Yellow has to go out all the way here. So 1, 2, 3, 4, 5, 6, 7. Red has to go out that way. 1, 2, 3, 4, 5, 6, 7. 8. 8. So this would be 1. Okay. This could be a merchant. And then this could be 2 and 1, and that does work. So 3, a foreign region does occupies 3 cells touching it. 6, there's no farmer. There's no merchant. There's not diplomat. So that works. This would then be it could be 2 or 1. This cannot be. This could be 4 still, actually. So we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This has to be 9. So far that's okay. This 2 eliminates Yeah, so this could be... One of these needs to be pink. Hmm. So far, this is looking fine. This can no longer have 4 because then it would be blocked off as a region. Could be 3, could be 2, it could be 1. This does touch at least 2 other foreign regions, so that's fine as 2. One could be either of these. 2 definitely could be here because it works as a farmer. 4 could be here because it's not... Doesn't fulfill merchant, doesn't fulfill diplomat, and doesn't fulfill farmer. Huh. Interesting. This is looking like a solution, actually. Okay, let's not try going down there then. What about 4 in the middle? That means you can't have 4 cells that are by itself. It cannot be touching 4 different regions. It can't have a region that's 4... That seems okay. What if we have this as a 2? That's interesting. Well, that's a merchant. That's fine. And as we showed, 6 works fine if this is pink right here. That's fine too. What about 3 here as a farmer? If we try to have 3 as a farmer, that means it can be touching at most 2 other foreign cells. Foreign regions. And at most 2 each. But... yeah, I could fulfill that. That's 5. That seems fine. Okay, this is tough. So 5 of orange is here. Oh, this can't be dark then. Right, so if we try to have this as dark, obviously all of these have to be dark to connect, because if it goes that way, it just... 1, 2, 3, 4, 5, 6, 7, 8, 9. That doesn't work. 1, 2, 3, 4, 5, 6, 7, 8, 9. It could go that way, but that's only a size 8 then. So that doesn't work either. I guess it could do something like that. 7, 8, 9. But the problem is this would then... it would fulfill farmer, but it would also fulfill diplomat. And it would have to be a diplomat, which is not allowed. So this cannot be dark then. So we know this is dark. This has to be a separate region because, again, this must have 5 orange cells in the at least out of the surrounding 6. Because if it doesn't, that means there are 2 other cells which are foreign, and it's either 2 separate regions which would fulfill diplomat, or 2 cells of the same region which would fulfill merchant. So 5 of the orange must be here. Um. Hmm. Say this was 4. If this is 4, it cannot be farmer, so therefore only 3 of the cells. That seems fine. And then another 3 cells could be of the same region, and it would not fulfill merchant. Or it could be 2 and 2, not fulfilling diplomat. That's fine. Yeah, so 4 doesn't seem to be very restrictive there. 4 doesn't seem very restrictive here either. 1 doesn't, it can't be, it could be 1 fine because we're guaranteed there's at least a different cells, different regions here. At least 2 different regions here because then this could be guaranteed. Say this was 4 as a merchant. So this would be all dark. This would be medium. And it would have to exit out that way. Could not be orange. This would have to be a separate region. This would be a separate region. So that would go that way. So this would have to be pink. Which means that could not be... Well, I mean, we don't know what that one is. That's fine. That would force this to be a 1. Okay, I mean, seems fine. Uh, so far, I don't know. A lot of the things we tried seem to be fine. Uh, 3. Say this was pink, right? So then this would be pink, pink. The red would have to go this way. It would have to go out at least this way. If it went this way, the problem is it would have to exit out. Because the merchant would have to fulfill the 3 here. But then this would never be 3. So the red would have to go out that way. Which means this would have to be all pink. So this would be red. So I think this has to go this way no matter what. Right? Say this wasn't red. Right? Then this has to be like, right. Say this wasn't this region. Then this region has to go out this way. I guess it could go that way. It would have to be at least 3. If it's red, I guess technically it could do something like that. Maybe. I think these 2 cells have to be the same region. Let's assume these are not. Then this has to be 3 cells. These are all the same region, and then this would be blocked. So that's not possible. So this has to be the same region. I don't know. I want to make this red then. And this essentially could be red or it could be yellow. So technically it could be red also. Oh no, it cannot be red. So if this were red, that means this would be red, and this would never fulfill the merchant constraint, which it has to. So this can never be red, which means that can't be red, but this could be some sort of yellow, right? Or this could be red. I guess this could be red this way and then red that way. That's possible. Hmm. So this is not guaranteed to be a different color either. Hmm. Neither is this, so... If this is red, 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 that means all of these are pink. Obviously, if this is yellow, yellow could go out this way, pink could go here, and then pink could go that way. It's possible. This is guaranteed to be red and red, though. Hmm. Okay, so what happens if this is all pink, right? That means this is pink. This all has to be pink. This is not yellow. This is red. That forces red to go that way. Uh, um, that means this can't be 2 because that would force us to be 6, but then that would fulfill the farmer criteria. Doesn't really help much. Mm. That's interesting. Hmm. I just got to thinking. What happens if any of these are 2s? So if this is if any of these are 2, obviously if this is 2, that has to be 1, guaranteed. But if this is 2, that means 2 cannot be here. 2 has to be in one of columns 1 and 2 for the green region. 1 through 3. That doesn't guarantee anything there then. Never mind. Obviously, if this is 2, this has to be 1. Hmm. Hmm. Oh, that's interesting. So if this is red, obviously this can't have four regions touching it. So this must, and this can't be red because you already have three reds here, and we need this to all be pink. So therefore, if this is red, this must be pink. If this is yellow, it has to be... It cannot go around here. Could. Red could go here and then around that way. So this is not guaranteed. This is not guaranteed to be pink or yellow either. Because it could be red. So this is... But this has to be pink, yellow, or red, specifically. Guaranteed. That doesn't really tell us much, though. If this is 6, which forces this to be 2, that means 2 cannot be here. In columns 1 and 2, the green region has to have its 2, and that's not true. 2 could be here. Dang it. Okay, that doesn't tell much. Okay, so this says 2, which means it must match the merchant role. This is a farmer role, so it must have at least 6 cells. Diplomat. Okay. Yeah, 2 is going to be easy to match because this is a different region, and one of these is guaranteed to be a different region because of this diplomat there. So that's fine. Obviously, one could be a diplomat unless it's surrounded by its own region. If this were 2, that's interesting. So say this was 2. Obviously, this would be 3. So you'd have no more 3 here. It would obviously not be... Oh, wait. Oh, no, that's not true. That means this would have to be a farmer and not a merchant or diplomat. So again, it would have the same issue with this. So this would have to have 5 be in the same region as this one. Well, let's say red was here. That means this would have to be a different region. And I think it would be yellow, and then the problem is the red could not go out. Because the red has to have all 3 in the same region. So then this would have to be at least yellow, yellow, and therefore that would be a problem. So this cannot be yellow, therefore this would have to be red. So since this is red, only one of these can be red here. If this is red, this is all pink. That's possible. So then if this is yellow, the yellow has to get out here, at least 3. And I guess this still could be red. Okay. So that's somewhat satisfied. So yellow could go out that way. What this cannot be... Pink could go that way if this is both red. And then this is red. Right? That seems fine. Okay, that doesn't lead to a contradiction either. I was hoping that would, but it doesn't seem to be. Two cannot be in the red region. Right, so this could be red, which would force this to be all yellow, but the yellow could go out that way. This is pink and pink, or yellow, yellow, yellow. That seems fine. Or this is all pink this way. That's red, and that would force red to be here, but that's fine. So that's valid, unfortunately, or doesn't lead to a contradiction, shall we say. There's a lot of these then. Ugh. It's trying to find a needle in a haystack, which way to target, right? Or which cell to target. None of them seem to work right now so far. What are the remaining digits of row 1? We have 1, 2, 4, 5, 6, 7, 8. 1, 2, 4, 5, 6, 7, 8. No 2, obviously, no 1. We have a guaranteed 4, 5, and 7 in the rest of row 1, but we don't know what the remaining cells are. What the remaining digit is. It's 1, 2, 6, or 8, but we don't know which one. Hold up. This is a merchant. It cannot be a diplomat. There we go. That's what we should have targeted. There we go. This is a merchant. It cannot be a diplomat. It already touches 1, 2, 3 other regions. So this cannot be one, two, or 3. Because if it's 1, 2, or 3, it's guaranteed to be a diplomat. Right? We have already 3 regions that it's touching. So this cannot be 1, 2, or 3. This must be a 4, which makes that a 1. Okay, well, there we go. So this 4 eliminates 4 in the rest of the column. This can't be 1. This can't be 4. This 4 means the merchant has to be 4. The only region that can be 4 then has to be here, which means this medium gray must go down this way. Okay, maybe I should... Well, it's too late. Okay, anyways. This is 4. That means this is 4 to satisfy the merchant, and it cannot be 4 for the diplomat. So this is done that way. This has to be 1, 2, 3. So these all must be separate regions. Yellow and blue. Because this must see 5. This is 1. That's 2. We only have 3, 4, 5 here. So this is 5, which eliminates 5 in the rest of the region and the rest of the row. So this is a border. This is a border. This is a border. This yellow must go down here. This light medium gray has to go that way, so that's a border. That's a 1, which is touching another region, so it works, is fine as a diplomat. This sees at least 2 other cells. It's not going to be a farmer, so it's not going to match 8. This could be 4. It could be... Can it be 2? Okay, this has to be pink. So this can't be... This is a different yellow. There's too many possible regions. But yeah, this pink has to go out that way. So this cannot be 2. If this is 2, this would be a merchant. Guaranteed. At least. So this cannot be 2. So this is 1 or 4 here. If it's 4, it can only have 3 cells. 1 could have any constraint. So this is pink, pink. You could have yellow, 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 potentially, going out that way. Obviously a different type of region. Okay, this is 1. So it's a diplomat. So that means it must be touching one other region that's not its own. Okay. Um, can this ever be... Huh. Can this ever be not pink? I think the answer to that is no. If this were not pink, say it was some other region, orange, the pink would have to go around here. So this would all be pink. This would have to be all red. This could not be 2 because it would have to be at least a diplomat because it would be touching 2 regions. It could not be 6. Actually, it could be 6 because it could be far... Oh, dang it. Okay, so pink would have to go all the way around here. This would be red. Red would have to go here. 1, 2, 3, 4, 5, 6, 7. Pink would have to go that way. This would be orange. Yellow has to go that way. That means orange has to go that way. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Orange has to go this way. Yellow has to go this way. Blue has to go this way. So this would have to be a 6 then, if that's the case. 1 or 2 works in that situation. 4 and 1 works in that situation. 2 could not be would have to be a merchant at least. So this could not be 2. This would be a 1-4 pair, which eliminates 1 and 4 in the rest of the column. Actually, we know this can't be 1. This can't be 1 because of the 1 in the row. Remaining digits in row 2 are 2, 3, 6, 8, and 9. And this can't be 9 because of the 9 in the column. Again, so again, this can't be 1, this can't be 1. This is 2, 3, 6, 8, 9. This can't be 9. We made that orange. What does that come up with? Again, pink has to go that way. This would have to be red because any other region would be blocked then. Pink has to continue that way. Red has to continue this way. Orange has to go out somewhere. So we have 1, 2, 3, 4, 5, 6, 7. That forces pink to be there. Red, therefore, has to go that way also, because that's 7 also. 8. Orange has to go that way because it can't go anywhere else. Yellow has to go that way. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9. Red. 1, 2, 3, 4, 5, 6, 7, 8, 9. Pink. Orange has to continue out that way. Yellow has to continue out that way. Blue has to continue out that way, which means medium gray has to go that way. Blue has to continue here because there's no other place. Yellow has to continue here because there's no other place. Orange also does. These are done. So orange could go down. Yellow has to go that way. Blue has to go that way. And then where does blue go? Blue has to go to one of these two. I guess blue could be part of this orange, right? This would essentially be the orange region. It would have to, right? 1, 2, 3, because it has to be part of one of these. So this would technically be orange, and then this one, I guess, would be blue. So that's satisfied. Since these are part of the same region, this would be 8. That seems fine. So this is all if this is not pink. Obviously, this can't be 2 then, because it would satisfy the it would have to be it would satisfy the diplomat rule, and so therefore that would not multiply to 6. So that's if that's blue. If this is not blue, I'm sorry, if that's not pink. If this is pink, what does that make this? Could it be 2? Possibly. It would not be able to fulfill diplomat, so none of these could be red. This obviously wouldn't be able to be the yellow that's here. So this would have to be all pink, which would force this to be red. Or this could be just 6. Okay, let's say this was a yellow then. So let's not focus on this cell, but let's focus on this cell. Say this was a yellow. That would force then all of these 3 to be yellow. Pink has to go that way. Okay, well, let's make this an orange or whatever. Pink would go that way. Orange has to get out, so it has to go that way. Red has to get out, so it has to go that way. Orange again has to go out, has to go that way. Pink has to go get some out, so it has to go that way. So this could not be 2 because it would be a diplomat and would not multiply to 6. It would multiply to 8, so this would have to be 6. Pink would go this way. Red would have to go that way. Orange would have to go that way. We still have only 1, 2, 3, 4, 5, 6, 7 orange. 7 orange, 7 red. So this would be red, orange, red, orange. Pink has to go this way. Yellow has to go that way. Yellow, this is pink. 3, 4, 5, 6, 7. Yellow, blue. This blue would match this orange, so this is technically orange, and I guess this would be blue. This would be done. This would be 6, this would have to be 4. Yellow has to go this way. Orange. Gray has to go this way. Orange has to go this way. 3, 4, 5, 6, 7, 8 pink. So these would all be done. These would all be done. You could have some other region. Okay, so yellow, 1, 2, 3, 4, 5, 6, 7, 8. So yellow does have to go this way. The problem is 5, 6, 7, 8. We have 9, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9. But we'd have 2 cells in a region which is not allowed. So we know this can't be here. This cannot be a separate region here. This can't be a yellow going down because the pink has to go that way, yellow has to go that way. That forces red to go that way, which means this is all structured. And then these end here. The pink would have to go to here. Yellow would have to go here. Blue would have to go here. So this is almost certainly orange, but we're just going to work with that right now. So this cannot be... Actually, we don't even know if that's the case, but whatever. This cannot be a separate region here. So it cannot be yellow. Therefore, this is red, red, red. So this can't be red here. This must be pink. Red has to go out somewhere. So red has to go here. 1, 2, 3, 4, 5, 6. If this is pink, it cannot be 6. It has to be 2. Right? Because if it's 6, that's 1, 2, 3, 4, 5 pinks, and the pink has to get out somewhere, so that forces a 6 pink here, which would force this to be a farmer. So if this is pink, it's a 2. So let's try that. What happens if this is pink as a 2? That means there must be a region here touching it, which has to have 2 cells. So it's either yellow, yellow, or this is red, red. One of these is pink. 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. Obviously this couldn't be 2 here. This has 3 cells in that region. That's fine. If it's pink here, this has to... I guess it could be yellow that way, going around. It could work that way. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then that could be yellow, yellow. Interesting. So this is either pink or it's like a blue. We're gonna make this orange either way then. Or maybe this should be blue. We'll make that blue and this potentially yellow. We don't know if this is the same region. It's very likely, though. Well, again, if this is yellow, cannot be 2 because it would be a diplomat. So this would be 6, which would force us to be 4. Pink would go all the way around here to get out. That's 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6. Red has to go that way. So does pink. So red goes 3 more here. Pink goes 3 more here. Yellow has to go all the way here. Blue has to go all the way here. Orange has to go here. Yellow has to continue out. Blue has to continue out. Orange has to continue out. This is done here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Blue has to continue out, which means, and gray has to continue out. Orange has to continue out there, and it must continue here, so which is why this is orange, which is why this is 8. So this seems fine. If this is blue, okay, so blue has to continue out here. 1, 2, 3, 4, 5, 6, 7. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this fails. Because the blue has to continue out going this way. Well, hold up. Blue could go that way. Right? If blue goes this way, yellow can't get 4. How does this work? So this has to be 4 as a merchant, which means a foreign region occupies 4 cells. So again, if this is not blue, the blue has to continue this way, but then blue has to go this at least 4. The problem, though, is this is all done as a region. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is done as a region. 9. So the yellow would have to fill the rest of this region, right? 1, 2, 3, 4, 5, 6, 7, 8. Say this was blue. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 would have to be all yellow. But obviously a region can only be 9 cells. So then that's with that being blue, not being blue. So say this was blue. If this is blue, either you have 4 cells as a region here, but it can't be orange because we already have 5 oranges. So this has to be a separate region, or we have to have 4 yellows. Well, if we have 4 yellows, these get, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we still have the 10, 11 that have to be yellow or pink or red, but they're extra, which is not allowed. So this never works. So this cannot be a different region. It has to be pink. So this is guaranteed to be pink. It will guarantee to have 6 then, if that's the case. So this can't be 6. This is 2, right? This would be a farmer if this was 6. Red has to go this way. This 2 eliminates 2 here. We have yellow here. This could be blue of some sort. So it must be either 2 yellows that way at least, or 2 reds that way. Or this way. No, it cannot do that way. If it goes that way, it blocks the pink. So it must be either 2 reds here, and this is pink, or 2 yellows, or potentially yellow going that way. We don't know. So it's 6. So where the pinks can go? Pinks can go 3 at least, at most. It cannot cut off the red. So it can go 3 that way, or up to 3 that way, and that's it. It cannot cut off the red. Okay, so this is guaranteed to be 2. It could be yellow, yellow. Um, uh, this has to be red. So we have 6 reds. You could go 1, 2, 3. You cannot cut off the pink, or 1, 2, 3. So these are red. This could be some sort of bluish. Oh, you could actually have another region here. And then the pink goes out that way. That's possible too. So it doesn't have to be red. Interesting. So that's the extent of pink. Oh boy. Obviously, yellow could be. Yellow cannot cut off pink. So yellow can go up to here so far. It cannot be part of the orange region because that would be 1, 2, 3, 4, 5, 6, 7, trying to get to the 8, 9, and then this would not be able to be a farmer just in value. It'd have to be at least a merchant or diplomat. So yellow, you could have 1 going here, potentially. So yellow could go up there. You could go 1, 2, 3, 4, 5. So 6, 7, 8, 9. You cannot reach the corner. So yellow can get to here. Obviously here, as long as it doesn't cut off. 4, 5, 6, 7, 8, 9. So those could be yellow potentially. Pink is done there. Blue, or some sort of thing, could go here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Technically, that could be blue. That's blue or orange. Oops. Orange could go here. I think any of these could be blue. Gray could technically go down here too. I guess blue could go down here. Would it be blue then? I don't know. Blue, orange. If it's orange, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Yes, technically it could go down 1. So orange could be 1 more here, connecting. Orange obviously could be any of these. Gray could go any of these. Hmm. Can this ever... Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Possibly. Technically, this could be orange also, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it cannot be orange. This is at least 4, 5. You need 5 around this 2. So if it's 1, 2, 3, 4, 5, 6, 7, 8, 9, it's at least a merchant with two cells in the same region, or these are two foreign cells. So this cannot be medium gray. It's its own region. It's not medium gray and it's not dark. That's interesting. How many cells can you have here that are dark or medium? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So can this actually be orange? We know medium cannot be the same as orange. Dark cannot be the same as orange because there's too many cells in the region then. Because there has to be 5 surrounding this 2. And then this is 5 already here. This is at least 5 here to connect. And then if you try to have a region here of dark and medium without the medium going down or the dark going down, you can't. Because that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because you only have 1 around this 2. That's foreign. 11, 12, 13, 14, 15, 16, 17. So dark, medium gray or dark gray has to be going through row 5 at least. And since that's the case, orange cannot just be 1, 2, 3, 4. So you have to have a gray here, at least. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, and 9, which means this can never be orange. Interesting. So orange cannot cut off medium or dark. So this is like some sort of blue region here. Blue could be here. Blue could be here. Orange could... No, orange... you can only have one orange. That means this can never be yellow. Because if yellow goes here, it will block off the blue. And the blue has to be here and would be part of this orange region. We know it's different than the gray region. So if the yellow ever goes to here, blue has to go this way and then would be part of the same orange region. That's not allowed. So this cannot be yellow. So yellow can never reach here. Blue could be here, though. Blue could be either of these, as long as it's just one of them. One, two, three, 4, 5, 6, 7, 8, 9, possibly. So can medium gray not ever be one of these two? So 1, 2, 3, 4, 5, 6. It has to go down. Yeah, it's impossible. So one of these has to be gray. At least medium gray. Okay. So this really can't be another region? If it were another region, pink goes that way, yellow goes this way, and then it's blocked. So this cannot be another region. So it can't, well, this one can't be. So it'd be either 2 reds or it's 2 yellows that way. We don't know which. Yellow has to go down. So if this is 3 pinks that way, yellow cannot go down. Yellow would have to continue that way, which would force blue to continue that way, and blue and orange would be in the same region. But then the medium gray and the dark gray wouldn't have a full region. So this cannot be 3 pinks. Therefore, the 3 pinks has to go this way. So this cannot be red. And this must have 2 for the merchant. So this is yellow. We don't know if that the yellow has to exit out, so this has to be yellow here. We have 1, 2, 3, 4, 5, 6, 7, 8, and 9. These can't be blue. That's all red. That's the only way to get out for those regions. So that's done as regions. Yellow's that way. Yellow has to go out. This blue cannot go out here. This can't be orange. If this is orange, this region is stuck. So orange cannot be here. That means this has to be blue. It could be... No, blue wouldn't be stuck here if the yellow goes here, right? That's the reason why. So this has to be blue. One of these is gray, so therefore this has to be blue here. And it could go blue that way or blue this way. But at least one of these is gray. These are both blue. This has to be blue. Can't be orange because that's 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Oh, it could be orange. Okay, so orange could be here. 1, 2, yeah. Orange cannot be here because it would be blocking off this blue. This could also be blue, technically. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's too many. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't think it can ever reach blue here. This is 6. Okay, so say blue tried to reach here. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is only 1, 2, 3, 4, 5, 6, 7 inside. So that's not possible. So this cannot be blue. Therefore, that's a yellow. What about here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Or 1, 2, 3, 4, 5, 6, 7, 8, 9. So if this were blue, yellow would have to be this. 5, 6, 7, 8, 9, 10. So this cannot be blue. Therefore, this is yellow. It can't reach orange there, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it could be orange. But if it is orange, that would block off the blue and the yellow to form a region. So that would not work. So this cannot be orange. This then has to be yellow. Can this be blue? 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, technically. This could be yellow also. This is at least 4 yellows here. So if it's 4, that would be a farmer. So this can't be 4. That's 1. Which means this can't be 1. The rest of green cannot contain 1. So this must be a 1 here. Which means 1 cannot be either of these cells. And it cannot be either of these cells. So 1 has to be one of these red cells here. 1 has to be one of these 2 cells there. So this can't be 1 here. This can't be 1 there. This is 2 or 4. 2. It cannot be 2 because that would satisfy the merchant here. Right? This is at least 2 cells, 4 cells. So this must be a 4. So this is a 4. The rest of column 4 must be 2, 6, 7, 8, 9. And this can't be 2, and this can't be 2 because of the 2 in the row and the 2 in the region. That means 2 is either here or it's one of those 2. We know 3 has to be one of these 3 cells here because it can't be in the red region. 7 has to be one of these 3 cells here. 5 has to be one of these 3 cells here. So this cannot be 5 or 7 or 3. What do we have? So 1, no 4 either. 1, 2, no 3, 4, no 5, 6, no 7, 8, or 9. We have to have a 9 in one of these 3 cells here. And this can't be 2 because of the 2 in the column. So 1, 2, no 3, 4, 5, 6, no 7, 8, or 9. And this can't be 1 because of the 1 in the column. This cannot be 3. Well, orange could be here, technically. No, because then blue's cut off. Oh. Both of these technically could be light. If you have blue going that way. This is a merchant. Okay, so this is at most 4. Because to be a merchant, it has to be one foreign region that occupies the most. And this can only be 2 at most. This is only 4 at most. So this is not 5, 6, or 7. It's 2, 3, or 4. Can this be a farmer as blue or yellow? And I think the answer to that is no. Can't be as an orange, obviously, and can't be as a gray. If it's blue, that's 1, 2, 3. I guess it could be blue. It could be blue. It could be blue. Can it? Hold up. If it's 6, obviously it's 1, 2, 3 at least, or 1, 2, 3. The problem is, to get 6, you have to have 1 in column 9. That's blue. And that would block orange. So then this would be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Oh, that's possible. 9. No, but then that would be 9. And then this cell will not have a region because the blue would have all 6 here, 7, 8, 9, but it would not be able to form here. And then yellow obviously doesn't work because we have 5 cells that are already not part of that 3x3 box. So this has to be a 4 either way. Which eliminates 4 in the rest of the column. If it's... Can it be blue? I guess orange could be here, right? If it's yellow, then blue has to be 1, 2... If it's yellow, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. The problem is 5, 6, 7, 8, and 9. How does that work? 2, 3, 4, 5, 6, 7, 8, 9, 10. So these would not have a region if this is yellow. So I think this has to be blue then. Since this is blue, it could have 4 oranges or 4. Can it ever have 4 yellows? 1, 2, 3, 4, 5. It would have to be 4 yellows that way. And then that would block off these cells from a region. So it cannot be 4 yellows. It must be 4 oranges. So these must be orange. 1, 2, 3, 4. And we have 5 around the here, so this can't be orange. So this can't be orange here, right? We have 4 oranges here. There's 5 around this 2. So that's all 9 oranges accounted for. So that means this must connect to the blue here. So this is blue. This is blue. We have 1, 2, 3, 4, 5, 6, 7 yellow. So these must be yellow. That's the only possible yellows left. This has to connect, so this can't be gray. This has to be a gray because, again, we need a gray here. These can no longer be blue. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's done as a region. The yellow's done as a region. The orange is kind of done as a region. This is medium gray. 1, 2, 3, 4, 5, 6. Only one of these can be gray. So this must be 7. 1, 2, 3, 4, 5, 6, 7. Only one, so this has to go down there. The dark has to get out somewhere, so this is dark, this is dark. Gray could go here. Orange has 1, 2, 3, 4, 5, 6, 7. This cannot be 6 as a farmer. It could be, it has to be 4 as a diplomat because it matches 3 already. So this is 4. So that means this can't be 4. It's a merchant. So it must be 2 or 3. It cannot be 2 because then it would be a diplomat. So this has to be 3. That eliminates 3 in the rest of the column. This can't be 3 in the blue region, so it must be 3 here. So this is 3, which eliminates 3 in the rest of the column. We have 1, 2, 3, 4, 5, 6, 7. Okay. We know this is a boundary. 1, 2, 3, 4, 5, 6, 7. We have 2 more. So 2 of these are orange, and then 1 of these can be medium. So we have 1, 2, 3, 4, 5, 6, 7, 8. 1 of these 3 is medium. The rest have to be dark. So this is all dark. 2, 3, 4, 5, 6, 7, 8. It could be 9 here or 9 here. So one of these 2 is dark. Diplomat is fulfilled there. That's fine. We have 4 already in the dark region. And 7. And 5. We need access to a 3 in the dark region. And it can only be one of these 2. It could be here too, actually. Never mind. So it could be here also. So the dark region 3 has to be one of those 3. Cannot be here. So it's one of those 2. Okay. This cell, we already have a 9 and a 1. Could be 2, cannot be 3. Cannot be 4, 5, or 7. So it could be 6 or 8 here. We have a 2, 6, 8, 9 quadruplet in row 3, which eliminates 2, 6, 8, 9 in the rest of the row. Therefore, this can't be 2, 6, 8, 9. It's 3, which eliminates 3 in the rest of the green region and the rest of the row. So the rest of row 3 has to be 1, 5, or 7. And this can't be 1 because of the 1 in the region. The dark needs access to a 3, so this must be dark, which means this can't be dark. So this is orange. One of these is gray, medium gray. So this is border of a region. These are borders. This is a 3. Obviously, this can't be 9 anymore. Therefore, since this is a 2, 6, 8, we have to have a 9 in one of these 2 cells. We also have to have a 9 in one of these 2 cells, so this green already has a 9 in one of these 2 cells. So this cannot be 9. This becomes a 6, 8 pair, which eliminates 6 and 8 in the rest of the row. This can't be 6 or 8, so it's 7. This can't be 6, 7, or 8. This can't be 6, 7, or 8, so it's 3 and 9, 3 and 9. This 3 eliminates 3 here, so it's 9, which makes that a 3. This gray needs access to a 9, and it cannot have a 9 here. There's no 9 possible here, so it must be here, and therefore this is not orange. This is gray, which means this can't be gray, so that's orange. So this is the regions. This 1 and 7 eliminate 1 and 7 in the rest of the region, so that's just 5, which means this can't be 5, that's 7, which makes that 1. Okay. This has to be a 2, 6, 8 triplet because those are the only digits remaining in the gray region, in the medium gray region. That leaves these digits as 1 and 8, and this can't, not 1 and 8, 1 and 5. And this can't be 1 because of the 1 in the row, so this is 5, that makes that 1. This fulfills either diplomat or just non-farmer, 8. So that's fine. Remaining digits in blue region have to be 2, 6, 7, 8, and 9. These can't be 9 because of the 9 in the column. This can't be 9 because the 9 in the red region has to be one of these 3 cells. So where is the 9 in the blue region? It has to be here. So that's 9, which eliminates 9 here. Okay, remaining digits in... So this 7 eliminates 7 here and 7 here. We have in the orange region, remaining digits are what? 3, 4, 5, 6, 8, and 9. 3 cannot be here. 5 can't be here. 3 can't be here. 4 can't be here. 4 can't be here. 9 can't be here. 3 can't be here. 4 can't be either of these. Where is the 4 in this orange region? Cannot be here, or here, so it must be here. So that's 4, which means this can't be 4. Where's the 4 in the dark region? It has to be that cell, so this is 4. We should have all the 4s then. We don't have the pink one. That's not good. I messed up. Apologies for that. It's not 157, it's 154. Okay, so there's the problem. 145, right. This can't be 4 and 1 because of the the medium dark region, so that's 5, which means this can't be 5. This has to be a 4, which means this can't be 4, that's a 1. Again, the dark gray needs access to a 3, so this is only the possible 3, so this is dark. This cannot be dark, that's orange. One of these is orange. This can't be medium because we have the 1 there. So this has to be orange, which makes this the medium. So that's still this. The shape is still the same. So apologies for that. That was a pretty big blunder there. Anyways, that eliminates 4 here. That forces this to be 4 there. We have 8 4s. We know where the last 4 has to be. It has to be there. Okay. Again, where are the 9s? This can't be 9 because of the 9 in the region. Where's the 9 in row 2? It must be in the light or the green region. Where's the 9 in row 3? It must be in the light or the green region. We already have a 9 in the light region, so this must be one of the 9s in the green region, so this cannot be 9. This is a 6-8 pair, which eliminates 6, 8 in the rest of the row and the region. So this can't be 6 or 8, that's 7. This can't be 6, 7, or 8. It can't be 3 because that's forced to 3 because of the dark region. So this has to be 9, which makes that 3. That should give us... we don't have enough. Okay. 2 and 9 are no longer possible in the rest of column 4. Rest of orange region is 2, 3, 5, 6, 7, 8, 9. So no 4. So 3 cannot be here or here. 3 is one of these 3. 9 cannot be here. What's the rest? Okay, so the rest of the median gray region is 2, 6, or 8. That means the remaining digits in column 7 have to be 1 and 5. This can't be 1 because of the 1 in the row, so this is 5, this is 1. That means 5 cannot be here, 5 cannot be here. So the blue region, again, is 2, 6, 7, 8, 9. This can't be 9 because of the 9 in the column. This can't be 9 because red has to have a 9. It cannot be here. So where's the 9? It has to be here. That eliminates 9 in the rest of the row and the rest of the column. So 9 has to be one of these 2. 1 has to be one of these 3. If this were 2, it would have to be a merchant because this pink forces this to be a merchant. So this has to be 1. Which means this cannot be 1 here. This cannot be 1 here. And this can't be 1 here. Whereas the 1 in the light region, it has to be here. Where is the 2 in row 2? Can't be here because of the 2 in the row. And the filled out region cells. And this is filled. And this can't be 2 because of the 2 in the region. Because it couldn't be 6. So that forces this to be 2, which means the rest of the region is not 2. And the rest of the row is not 2. That means, we have a 2 is not 2. So that means the rest of the column in the dark region has to have a 2. So this is 2, which eliminates 2 here. We have a 2, 6, 8 triplet in column 6, which eliminates 2, 6, and 8 in the rest of the column. So this has to be a 5, 7 pair here. Since this is a 5, 7 pair, that eliminates 5 and 7 from the rest of the column, or the rest of the region. So this is a 6, 8 pair, which eliminates 6 and 8 here. So that's 7, which makes this 5, which makes that 7. The remaining digits here are 2 and 9 for the yellow region. That eliminates 2 and 9 in the rest of the region. So where is... We have a 6, 8, 9 triplet in column 1, which eliminates 6, 8, and 9 in the rest of the column. This can't be 6, 8, or 9. It's 2, 5, 7. This is a 6, 8 pair, which eliminates 6 and 8 in the rest of the row. So this can't be 6 or 8. This can't be 6 or 8. This is 9. This is a 2, 7 pair, which eliminates 2, 7 in the rest of the row. So this is 5, which means this can't be 5. This can't be 5. This 7 eliminates 7 here, so that's 2, which makes that 7. This can't be 2 or 7. This can't be 2 or 7, so this is 8, which makes that 6. That eliminates 6 in the rest of the column. This can't be 6. This can't be 2 because of the 2 in the column, so this is 7. That's 2. 7 is eliminated here and here. Where's the 7 in the orange region? It must be one of these 2 cells, and it can't be here. This 7 eliminates 7 here, so that's 8, which makes this a 7. This 8 eliminates 8 here, so it's 6 and 8. This can't be 6 or 8, it's 2, which makes this 6, which makes that 8. This can't be 6 or 8, it's 3 or 5. None of these can be 8. Where is the 8 in column 9? It must be here. And the remaining digit here is a 5. That forces, this 8 eliminates 8 here. So this has to be a 2, 6 pair, which eliminates 2 and 6 in the rest of the region. And the column, so this is 8, which makes this 6. This can't be 5, 6, or 8, so it's 7. This 8 eliminates 8 here, so it's 6. This can't be 6 or 8, so this is 9, which makes this 8. This 9 eliminates 9 here, so it's 2 and 9. 2 eliminates 2 here, so it's 6 and 2. This 2 eliminates 2 here, so it's 9 and 2. This cannot be 9 or 3. This can't be 5 or 6 because of the 5 or 6 in the row. This is 3 or 5, but it can't be 5 because of the 5 in the column. So this is 3, which makes this 5, which makes this 6, which makes that 9, which makes that 3. The remaining digit in row 6 is a 3. And we have, no, not 3, it's a 6. That 6 eliminates 6 here, so it's 8 and 6. Remaining digit in column 3 is an 8. Remaining digit in column 5 is a 1. This has to be a 5. And this must be a 9. Woo! That's, yeah, that was pretty hairy. I should have been able to see this earlier, much earlier. I was stuck on this one for a while. But, yeah, pretty cool logic, actually, with the farmer, merchant, and diplomat. Yeah, some pretty interesting deductions you can make from this. Anyways, I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.